Welcome to Summarize Science, where we dive into the latest breakthroughs in planetary research. Today, we are looking at a fascinating study about why Venus and Earth took such different paths. Even though they started as similar neighbors, Venus ended up with a massive, crushing atmosphere of carbon dioxide. For a long time, scientists have wondered if this thick atmosphere is proof that Venus was once habitable like Earth. This paper explores whether that huge blanket of gas is a smoking gun for a watery past or just one of many possible outcomes. On Earth, most of our carbon is safely locked away in rocks called carbonates, thanks to our oceans and plate tectonics. In contrast, Venus has kept almost all of its carbon in its atmosphere, creating a surface pressure 92 times greater than Earth's. The researchers used complex models to test 3 different ways this could have happened. They looked at the initial cooling of the planet, volcanic eruptions over billions of years, and the breakdown of rocks during a climate catastrophe. Interestingly, the total amount of carbon on both planets might actually be quite similar despite these different storage locations. One major finding is that simple volcanic activity on a planet without plate tectonics might not be enough to build a Venus-like atmosphere. On a planet with a stagnant lid, where the crust doesn't move, the interior eventually runs out of gas to release. The models showed that this path only creates about a quarter of the pressure we see on Venus today. To reach Venus levels through volcanoes alone, the interior would need to be much richer in carbon than we currently expect. This suggests that other processes, like early magma ocean cooling, must be at play to create such a dense environment. If Venus did have a temperate, Earth-like past with oceans, it could have stored a significant amount of carbon in its crust. However, if the sun got too bright or the climate shifted, a runaway greenhouse effect would have taken hold. As the planet heated up, the heat would seep deep into the ground and destabilize those carbon-rich rocks. Within just a few tens of millions of years, the stored carbon would be baked out of the rocks and released into the air. This process could quickly transform a habitable world into a suffocating one, as shown in the researchers' heat propagation models. The most important takeaway from this study is the concept of equifinality. This means that multiple different evolutionary paths can lead to the exact same final result. A planet could be born with a thick atmosphere, it could build one through extreme volcanic activity, or it could release one from its rocks after a climate collapse. Because all these paths look the same in the end, a massive carbon dioxide atmosphere doesn't uniquely prove that a planet was ever habitable. This makes it much harder for astronomers to diagnose the history of distant exoplanets just by looking at their gases. To truly understand a planet's past, researchers will need to look for more than just carbon dioxide in the future. They suggest we might need to find other chemical or isotopic tracers to tell dead Earths apart from planets that were never habitable. This research is a major step in refining our search for life beyond our solar system. It reminds us that appearances can be deceiving, and a hellish planet might have many different origin stories. As we launch more powerful telescopes, these models will help us decode the mysteries of the cosmos. In summary, Venus remains a mysterious world that challenges our understanding of planetary evolution. Its thick atmosphere is a shield that hides its history, but science is slowly finding ways to peer through it. Thank you for watching Summarize Science, and stay curious as we continue to explore the universe.